Hey everyone, today we're going to continue the discussion with the second gen MR2. Specifically, we're going to talk about tachometers and how to make them work with your V6. So I wanted to get in here for a couple reasons. First of all, my tachometer is broken, so we're going to need to fix it, and there's a perfect teaching opportunity right there. And second, it's actually pretty easy to modify this thing to take a V6 signal instead of an I4 signal, so might as well do it. It's a good teaching opportunity, and will save you $80 to $100 on your build, which I'm sure everybody can appreciate. So let's check out the problems. So you've got your tachometer in your cluster. With it out of your cluster, it looks a little bit like this. This may or may not be there. That's just for the security light. And if you pull it off of that module, now keep in mind, you won't actually have to go this far. This is what you'll see. And the reason these tachometers start reading erratically or start reading low is you've got this electrolytic capacitor right here. This one works in conjunction with this resistor, and this resistor, and creates this voltage that determines where the needle should be. And it feeds that to the second half of this chip, which drives this sine-cosine motor to put the needle at the right place. Well, electrolytic caps, while these are really nice caps, they do have somewhat of a lifespan. So first thing we're going to need to do is we've got these lovely Panasonic 10,000 hour caps. We've got to put them in here to replace these, which will make the needle work again. And then we have to change two settings on it. First, the fact that the stock input is expected to be a much higher voltage input, down to a 0 to 12 volt input instead, which is what the ECU is actually going to be feeding on this. And then the other thing is the summation point here needs to be at a lower voltage because the frequency coming in is higher for a given needle position because you've got 50% more cylinders. So I just want to demonstrate my test bench right here. So this is just a cheap power supply that I bought with a cheap signal generator, and this is actually a tachometer module out of a V6 Avalon because my signal generator can't actually generate a high enough signal to drive the stock MR2 gauge clusters. We're going to fix that. So right now I've got it set to 12 volts, and you can see when I change the frequency, it moves the needle. And the sweep is about 270 degrees. That's great. And we can also use this to calibrate our values. Now, what you're going to need for this job, and there's links to it all in the description, is a soldering iron, some solder, some appropriately rated capacitors. I'm going to sell a small kit on the site, but all the values are going to be written in the description also. You can just source your own for much less money probably. And some appropriately rated resistors. You're also going to need some kind of cutters. I really like these flush cutters. Again, there's going to be a link in the description, but any kind of cutters will work for this. This doesn't need to be precision work. And some solder wick. Now, thankfully, these circuit boards are single-sided, so you won't even need to invest in a solder sucker. Though, by the way, I really like this one if you're looking for one. So step one is take apart your cluster. It's not too hard. You've got these clips here. You take the clear plastic off first. Just kind of push them in. And you can just do this with your fingers, though you can use a screwdriver if you want to. Just careful not to slip. The surface is really easy to scratch. We just kind of push it all around. And once you get all the clips pushed in, just gently lift up. And it comes off. Put this in a safe place. Next, we take off the black plastic. And same way, you don't need any tools. Just kind of push and slide it a little bit. Then we're going to do the same on the back. There you go. And find another safe place for this. Most of you guys obviously won't have this. There's simply going to be nothing in the middle here. And then we just want to take the tachometer out. So flip it over. With the automatic transmission, you got to take this part off here first to get to the third screw. Without it, this just won't be there. Keep in mind, this is a 91, so it has the cable-driven speedometer. If you have a 93, if you have a 93, the speedometer will be electronic, and you can see the 3 screws have been removed here. If you have the security module, the 4th screw also has to be removed here. So let's carefully extract this. Okay. And then you've got these 3 screws. And careful, the washers can be a little bit sticky to this plastic plate with copper on it. So definitely don't use any power tools here. Just kind of take them off gently. And the washer is captured, so at some point, see, it'll start pulling it up. Just gently push down on the copper. There you go, it separates. There you go, and that's all that's holding the tachometer in, so it kind of fell out the other side. There's your tachometer. So, side by side, we've got a 5 SFE tachometer and a 3 SGT tachometer, and difference obviously is the red line and the sweep. You know, one goes to 9,000, the other one goes to 8,000. This was what I was recommending back in the day because that's right about the red line of the stock ECU, but these days these are really great because that's actually the red line of the modified ECU that I make. It's actually 7200, so it's about here, not 7350 or whatever that exact mark is there, but that's close enough. But also back in the day, what I said is you should just use your turbo cluster and get an NA gauge face because the clusters were $20. These days, the clusters are $300, so don't do that. Just modify what you have. It doesn't matter if it goes to 7200. You'll know where your red line is, and if somebody else is driving your car and they stop at 6200, well, that's probably better for your car anyways. So there's a couple different ways to tackle this. If you have a naturally aspirated tachometer, here is the tachometer out of a early 90s Toyota Avalon with a V6, and this is the module out of it. Now, the module has a slightly different layout, but it's the same chip, it's the same driver, and it's the same bolt pattern. You can actually pull it right off of the back of this and put it on the back of there, and you're good to go. Everything works, the bolts line up, it's perfect. And you can often get these Avalon gauge clusters for 20, 30 bucks. There's nothing much that needs to be covered on how to do that. It's pretty straightforward. What I'm going to do instead is talk you through the process of upgrading this thing. So I'm going to do all the work on this without disassembling this, but just something to know. If you do want to disassemble it, the only hard part is removing the needle, and the trick there is just to use a fork. Slide the fork underneath, apply even pressure, pull it off. To put it back at a calibrated location, you apply 12 volts across where it goes, and you can see right on the cluster here it says ignition plus, ignition minus. So 12 volts and ground right here, and that will hold the needle at 0. So with the 12 volts applied, you hold the needle at 0 and you put it on, and then you're going to be good to go. If you do it without power applied, your 0 point's going to be somewhere around here. It's not a big deal. You can pull it back off and put it back on. The fork is the secret. Anything else and you're likely to scratch the gauge face. But without pulling it off, this is what we're going to do. And conveniently we can do it without pulling it off because the circuit board is one-sided. You can see there's copper on that side of the circuit board, but on this side of the circuit board there's nothing. That means the through holes on the circuit board won't have solder in them, so it's just all around a lot easier. So first thing we're going to do is we're going to make this tachometer work. That's going to take 2 of these capacitors, and then we're going to remove the 2 that are on here. And as you can see here, it's this one here and this one here. And they're both the same value. You don't have to worry too much about it. So to get them off, oddly enough, it's actually usually easier to add a little bit of solder first. I'm just going to reach down there and kind of tilt it to one side, pull one leg out, and then just kind of pull down on it, and there it goes. Capacitor's removed. Now these are physically much smaller than this, but the value written on the side, well, This one's actually got paint on it, but it's 10 microfarads. The reason these are bigger is because it's a slightly higher voltage, slightly higher temperature range, and longer lifespan. I'm going to get the old solder off with some solder wick. And see, these single-sided boards make it super easy because a little bit of solder wick and your hole's right clear. Now we check the spacing. You don't want to solder on this side because there's plastic in the way, but you can use it to check your spacing. And the other thing to keep in mind is, see, there's a negative side on this, and the ground is the post right here, and you can see it's connected to that pad. So we put it in this orientation. A little tricky to get it in there. There you go. Spread the leads a little bit so that it holds in place. And clip them to make them nice and short. You might have to clip them before bending them over if you're not using flush cutters. And then just a quick dab of solder. There you go. All right. Now let's do the other capacitor. Same value, so you don't have to worry about mixing them up. It's down here. And it's this one and this one. Add solder. And tilt it to one side to get it out, and then to the other side. It was not quite wanting to come out, so no problem. We'll just grab it. There you go, and it's out. Solder wick. There we go. We got open holes again. Grab our capacitor. Remember, negative pin, and it's still the same. You know, this is the ground terminal, so this is the ground plane. So negative has to be to that side. You can check the pin spacing by trying to put it in on this side. There we go, held in place, and let's trim it. Here we go. And solder it. And there we go. Now, if you were putting this back into your 3S GTE, you're done. But if you're using a modern ECU, we need to reduce the voltage requirement coming into this. And this is the signal input. And if you look at that signal input, here it is on this side. And you can see the only thing it goes to is right here, this resistor, and the high voltage units here have about a 60K resistor, and these ones have about a 24K resistor. So we don't even need to remove components because we're trying to reduce the value. What we're going to do is we're going to take this 51K ohm resistor and we're going to put it in parallel with the current one, and that'll give us the appropriate value. So let's do that. Just going to kind of bend it down so the leads are a little bit further down. We're going to add some solder over there because I don't have 3 hands. There we go. And there we go. Trim the legs. And now, if the swap you were doing was a 4-cylinder with a modern ECU, you're done. And let's go ahead and demonstrate this. Green is ground. Goes here. Red is 12 volts. Goes here. And then this is the signal. And of course it needs to have a common ground. So we should have, there we go, a working tachometer. Now what you can see here is, let's see, 6,000 RPM, takes 200 hertz. Now that means we're calibrated for a 4-cylinder right now. But now it's being driven with a 12 volt signal, which is great. Just that one cheap resistor. And now we've got a working low voltage input 4-cylinder tachometer. So what we're going to do is we're going to adapt it to a V6. Now, what's going on here is this resistor and this capacitor are working together with this chip to create an appropriate voltage for the other half of this chip to set the angle of this needle. Now, both these resistors are both pulling to ground, and what we're going to do, we're going to use a variable resistor right here. This is just a 10 kilo ohm resistor, which is a good place to start. We're not going to leave that in the circuit though. We're just going to use this to determine what the appropriate value is. And since we're trying to drop the voltage to drop the needle, we don't even need to remove any of these resistors. This is soldered across this resistor right here. And we're just going to decrease the resistance until we read appropriately. Now, the frequency counter right there is going to be set to output 300 hertz, which should be 6,000 RPM on a V6. So let's get that started. And now this is at the end of its travel. It's at 10K, so it's not reading what it should on a 4-cylinder or a 6-cylinder for that matter. But we're just going to tweak this, see how that's dropping, until it gets to the point where it's reading the right value, which for 300 RPM, which for 300 hertz should be 6,000 RPM, because 300 hertz divided by three cylinders per revolution, so it's 100. So 100 revolutions per second times 60 is 6,000 for 6,000 revolutions per minute. So right there. Now keep in mind, the component values here, if you look at the band on here, Toyota's just setting these things, they're gold bands, so they're plus or minus 5%. The tachometer is not super accurate to begin with. We're going to try to set it as accurate as we can here, but keep in mind, the needle's going to be off by a couple hundred RPM on everything, on every application. So now we can test it, make sure we can get a full sweep out of this. So let's see. Yeah, see, we can even get, roughly 10,000 RPM right there. Not a problem. And 100 hertz input is 2,000 RPM. 200 hertz input, yep, 4,000 RPM. So this is good. Let's figure out what value we've got on this, and we'll replace it with a resistor. And we have to take it out of line from the rest of the circuit to figure that out. Looks like 3.5K. Let's go get that. So my collection on hand is a bit sparse, but if I use these two resistors in parallel, I should get pretty close. So that's going to go between ground and this node here in the corner. And there we go. And note, the kit on the site will actually come with the right value in one resistor. You won't need to put two resistors on there. This is just because I have a limited selection at home, and I didn't feel like waiting to get more. All right, so let's give it 100 hertz. That should give you about 2,000 RPM. That's pretty close. And 200 hertz, 4,000 RPM. Yep. And 300 hertz. Yeah, I mean, maybe that's a reading 100 RPM low, but again, it's 5% tolerance on all this stuff. So don't mind that. I've just got some loose wires. 350. And there we go. So I'm pretty happy with the accuracy on that. We are done with this conversion. So keep in mind, the 3.5K calibration resistor is for the naturally aspirated tachometer. Now, we're going to go ahead and figure out what the value is for the turbo tachometer so that we have that number also. Just to get you a better view, the one capacitor goes across this one. The other one goes across these two. This is the resistor that drops the voltage on the input, and then the other resistors are going to go across here to drop the range on the tachometer. We actually reset the 0 point on this gauge earlier, so we're going to have to reset it. So first thing we're going to do then is we're going to hook up just power, because we can't calibrate it without having a good 0. So power goes down here and to the side. And we'll apply power. See, we're about 3,000 RPM. So grab our fork, pull it out. Now this one's actually missing. It's missing the peg there. But we're going to go to 0. There you go. That, if you're looking at it straight on, is 0. Okay, and now we're going to give it a 300 hertz signal to get to 6,000 RPM. And then we're going to calibrate it. Signal, and the signal ground. And there we go. So let's adjust it down. There we go. All right, I'm happy with that. Let's figure out what our resistance is. And our resistance on this thing is 1.31. All right, let's go see what we can find close to that. 1.8 and 4.7K together is 1.3. All right, let's try that now. What was that, 50 or 100 RPM low? That is good enough. And that value was a little bit low. The value that'll be included in the kit will be a little bit higher than that. It's just the best I had with what I had on hand. So now I'm ready to reassemble this gauge cluster. Let's go ahead and do that. There's two little holes there and two little clips, so these clip in there. That all goes in as one assembly. So have that back in there and get your 4 screws in place. And of course, don't get stupid tightening these. They just need to be snug. And there we go. Let's put the top covers back on. The black part next. Now, normally your gauge won't have this issue because you'll have a peg there, but I'll just lift the needle up. And then the clear plastic. Just line it up, push it on. And we have our reassembled gauge cluster with the turbo gauge trapped. All right, looks a little janky with the lack of stop there, but that's fine. Let's go put it in the car and test it. All right, and let's see what happens. So, key on, engine off. We're at 0 RPM. And there we go. And there you go. Hopefully that was pretty useful, how to fix and adjust your tachometer, and also how to figure out how to adjust it if you had a V8 or something. The same kind of technique can apply to pretty much anything as long as it's not driven by CAN. So any older tachometer, even some of the current ones still work like this, but less and less. But generally the ones that don't work like this will just take a CAN message, and it doesn't matter what engine you put in there as long as you're sending the right CAN message. You don't need to recalibrate them. So thanks for watching. Hopefully you found it useful, and we'll see you guys later.